maybe a second proposal for also SystemC 4. Its capabilities for exploring the hierarchy and especially the connectivity. Now, what's the motivation? Especially for us as a tool vendor, it's important to have interfaces where we can connect to virtual prototypes and to build tools around of it. As a typical tools we have is a kind of hierarchy explorer or an exploration of also the connectivity of an insight in virtual prototype. We want to do back annotations to maybe graphical representations. We might want to make back annotations of simulation results and all. Therefore, we need some capabilities to analyze at the end how the signals are bound, how the ports are bound inside running virtual prototypes. This is one of our motivations. Then what we are also doing, especially in the AMS side, we're doing static analysis of signal passes, maybe through the system. We're analyzing statically by properties the gain, or we're analyzing the noise. And all for this analysis we need to analyze also the connectivity between the different modules and also the connectivity through the hierarchy. Also, it's not only to know which signal is finally bound to a port, we must also know which ports are bound. We have also to analyze the port-to-port binding. And sometimes we have to do rule checks. Therefore, we must also know what is the binding. Then, maybe another application, therefore, is for TLM. If you have an initiator and you have different targets connected, then it maybe makes sense to statically analyze which targets are connected, maybe to do a kind of automatic generation of the address map to automatic determine the index of the binding then. And then finally, we need debug tools, and maybe we want also to create debug messages where we say what is connected to a certain port, how a certain port is bound. And maybe one figure how binding is working in the SystemC. Only classical signal binding is this. That means we have a hierarchical design. We have different child modules and we have primitive modules. And if we binding hierarchically, then we have this port-to-port binding, and usually at the highest level we have instantiate the signal and bind directly the signal. And if what we have today, if we elaborate, then you see only the signal which is bounded to a port. That means also if you are here at the primitive level, you see only that this signal is bound to the port. You have no chance to see that in reality there is a port bounded to this port. So that's make it sometimes very difficult to create tools. Maybe what is the current state for this hierarchically connectivity exploration? So what we have today in SystemC, we have capabilities to explore the hierarchy. Also we have this SC-get top level object. We can get the child objects, or we can also go upwards with get parent objects. That means we can find, if we have a module, we can find out which ports a module has. For TLM sockets, it's a little bit more difficult. It's not so straightforward because an TLM socket usually consists of a port and an export, and they are not directly connected, but indirectly you can also recognize the TLM socket, and you can recognize what belongs to the TLM socket then. Port-to-port binding, it's relatively difficult to analyze currently. You can do it only indirectly. It's very tricky. It's not always possible in this case. And to analyze if a port is bound to an interface directly, it can also not be analyzed because a port maybe can be bound to a port. That means you cannot really distinguish after elaboration if you have a port-to-port binding or if you have a port-to-interface binding then. Okay, a TLM binding I mentioned before is very tricky. It's also currently not directly possible if you want to analyze, if you have a signal, if you want to analyze to which ports this signal is bounded. You can do, of course, it always indirectly then. And SC export is also very difficult to analyze how an export is bound then. Maybe some proposals we have now for additions in SystemC to enable this a little bit more powerful exploration. Yeah, is one additional few additional methods to the SC port base class. That means that you can ask how many elements are bound to a certain ports, that you can then access to the so-called bind element. Also in the current implementation, that bind elements are existing, but maybe we can define this and make it accessible. And also that we can store it after elaboration inside the element, so that we can access to this, and then we can easily analyze, okay, to this port originally there was bound a port, or there was bound directly an interface, and so that you can access then via the index to this elements here. Now, what's maybe also required, currently the port has a method get interface, but there is no method available to access an if a port has multiple interfaces bound, it is currently not possible to access directly to an interface with a higher number than 0 as with the index. And similar, we need then also for the exports, we need also, we have to analyze whether there's an interface bound to the export, or it's in hierarchical binding, and export to export binding then. So, also for the interface class, which is the base class for all signals, we propose to have some additional methods which allows us to get the ports which are binding this interface, and maybe also to get the exports which are binding this interface to doing the analysis. Now, TLM sockets are principally very tricky. It may becomes a little bit difficult to have the analysis for TLM sockets. Also, principally, it could be easy. They consist of SC export, SC port. You could use these elements for analyzing the connectivity. The sockets themselves currently have no binding information. That's maybe a solution that we are adding this then. But if you go a little bit more in detail, then you see that the SC ports and export maybe, or first the SC ports and export, you cannot always directly recognize to which socket they are belonging. You can do it indirectly. And what's maybe the bigger issue is that the interfaces which are bound to the ports and export after elaboration has maybe nothing to do with the targets or the initiators which are bound to these interfaces, because there are some intermediate interfaces sometimes in between, and this makes it then extremely difficult to analyze what is the connectivity after elaboration then. Now, what is the current state? We have first proposals now for the SC port base, SC export base, and for the interface. And what's still open, I mentioned before, is how we're dealing with TLM sockets, because there is some tricky stuff included. Maybe we implement in special exploration for the TLM sockets on basis of the TLM socket base classes, and not use the SC port and SC export mechanisms there. Then there's also some first implementation available to do some testing, and also some first examples are available then. Okay, is there any questions?
Thanks, Karsten.
Karsten, you mentioned this struct in the port, and you also have getters. Is the intention to also make the struct part of the LRM, or only the getters?
No, it should be also the struct, because we must be able to analyze what is bound there. So currently this struct is existing in the implementation, but what's currently not done is after elaboration, this information is deleted, so that you cannot after elaboration access to this information anymore. So that's but after elaboration, currently you cannot analyze whether a port bounded a port, or whether it's bounded an interface.
Wouldn't it make sense to use stud variant here, since we are talking about C++ 17?
we could discuss. Yeah, why not? Yeah, that's maybe makes sense. Yeah. But this was defined before
Yeah.
this. But this is maybe a good proposal. Yeah.
Karsten, how do you handle multi-ports?
Now this is index. You mean multiple binding?
Yeah, I can't remember what they're called.
We have the size.
Okay, all right. Yeah, and you can pass the index.
The port has this method standard size, but this is how many interfaces are bound. And I introduced here a special size for this bound element so that we can maybe distinguish this.
Okay.
This is maybe different because if you have hierarchical binding, then the size, we say you have bound 5 interfaces, but from the hierarchical binding, it's only one port-to-port bounding that you have.
Are there any other questions? I'm optimistically hoping that people on this call are going away with the idea that not a huge amount is happening in SystemC4, and there is possibly space for people to come with more radical, interesting ideas.